If you have an Anker F3800, you're going to want to stick around because I've been doing some very interesting tests on the battery expansion port. Now, a few weeks ago, I came across a video by Noise Lab who determined that whenever the Anker F3800 is powered on, you actually get direct access to the internal battery through the battery expansion port. Now, just to demonstrate what I mean, I have a simple voltmeter here connected to the battery expansion port. You can see we're getting 52.7 volts. So with a simple hack of the battery expansion cable, you can get direct access to the internal LFP battery on this power station. Now, why is that important? Well, the F3800 has its quirks. For example, when you AC charge the power station, it shuts off the 240 volt output. These solar charge controllers have a 60 volt limit, which is kind of hard to deal with if you want to have a large array. And also, the expansion batteries for this unit are expensive. But with this cable here, you can get around each of those issues. Now, before we jump into the actual testing, I just want to clarify that there's always a risk when you are modifying or experimenting with a power station. So any modification or hack that you make to the F3800 will void the factory warranty. So continue at your own risk. So the goal of this video is to see what happens if I use this modded cable to connect up battery chargers, external charge controllers, or even standalone batteries to this expansion port. Let's do some testing. So in my first test, I want to see what happens if we connect up a 48 volt lithium iron phosphate battery charger to the expansion port. So for this test, I have the inverter enabled. I'm running a 1000 watt load through this heater. Now, if we zoom in on the screen here, you can see we're pulling about 930 watts, and it's estimating 2.9 hours until the battery is empty. So let's see what happens as I connect in the charger. Okay. Now, if we zoom in on the screen here, you can see the output is still the same. There is no input on the screen from our charger. But look at this. Remember how before it was showing 2.9 hours until the battery died? Well, now it's showing 22.7. So the BMS and the battery are definitely calculating the power coming in through that port, and it's estimating the runtime. So we are offsetting this 900 watt load or so with the 1000 watt charger that's connected. Now, in order to finish out this test, I've shut off the heater, and I'm gonna let this charger completely fill the power station to see what happens. Will this get up to 100% state of charge? Will the BMS shut off the charger? We'll find out. You can see that it's already jumped up from 86 to 87% state of charge. And also the estimated time remaining is 99.9. So it's definitely sensing power going into the battery. So the power station just hit 100% state of charge and the BMS shut off the charging. So the charger automatically stopped. Now, in my next test, I want to bypass one of the biggest flaws of the F3800, and that is the fact that you can't fast charge this power station with AC power. And whenever you are AC charging it, it shuts off the 240 volt split phase output. So to bypass that, I have the EG4 Chargeverter here. This is essentially a 5000 watt AC battery charger, and I have that connected up to the battery expansion port. So I've started the test and I'm powering the EG4 Chargeverter with the F3800 plus 240 volt output. Now, if you look closer at the screen here, you can see that we are pulling 2000 watts from the power station to charge the other power station. I have the voltage output set to 55 volts as the peak output, so we aren't able to get the full 50 amps, but we are getting about 33.5 amps peak. Let me just go into the settings here to see what I have this set to. So voltage is 55, state of charge start is 50%, battery start is 49 volts, current is 50 amps, state of charge stop is 100%, and battery stop is 56 volts. So I'll probably have to mess around with these settings, but this is what I have it currently set to, and it is working. Now, it's only been a couple minutes, and you can see the power station is charging very quickly. And the good news is, up here you can see that the inverter light is still enabled, meaning that the 240 volt output and the 120 volt output are still working because we are essentially DC charging the power station through the expansion battery port. Now, I've set up my clamp meter on the output of the Chargeverter just to get an idea of the amperage going into the power station. You can see it's right around 30 amps. And as we get closer to the power station being at 100%, we are going to see that amperage drop down because we're getting close to the peak voltage. So if the power station was really empty, we'd probably see near the full 50 amps input, but because it's getting up to 100%, it's going to taper off that charging. So just a few minutes later, the power station hit 100% state of charge, so the Chargeverter did successfully fill up the power station. So let's move on to the next test. I've discharged the power station down to 94%, and now I want to see what happens if we connect up external solar charge controllers to that input. So right here I have two EPEVER 40 amp solar charge controllers. These are 48 volt lithium charge controllers. You can see that I have them tied directly into the cable here. Now I don't have the solar arrays on yet. I have these breakers disabled, so let's turn them on and see what happens. I have them connected up to my 1600 watt array and my 1200 watt array. These are the larger solar arrays that I have, so here goes nothing. So these are successfully charging the power station. Let's see how many amps. So we're getting 23.8 amps and 1.3 kilowatts from that array. And then we're getting 17.6 amps, or about 1,000 watts from that array. Now this is really cool because these two solar arrays are high voltage solar arrays. For example, this is 4 400 watt panels in series for about 140 volts. And then this one right here has 3 400 watt panels wired in series for around 100 volts. So if you remember, the F3800 has the 60 volt charge controllers. So you can bypass that using your own charge controllers and solar panels in series. Now the power station is charging really fast with that solar input, and I wanted to demonstrate that you can also run 240 volt loads off the inverter while you're doing this. So I have two 120 volt heaters plugged into each leg of the 240. Now those heaters are pulling about 1800 watts, and look at the remaining time till empty. It is showing 81.6 days. So that means that we have more solar coming in than power going out, and the battery is sensing that, and the battery is almost full. Now what if you wanted to run a larger load on the inverter? Would the screen update? I've turned up each heater to high mode. They're each pulling 1500 watts. You can see right under 3000 watts total on the screen. And yes, the estimated time remaining on the battery has changed. It's dropped down from 81 days down to 5 hours. So typically, if you were running this type of load on the power station, you'd get a little longer than 1 hour of runtime. But with that extra solar coming in, you can see that we boost the runtime to about 5 hours. But I wanted to do one other test. So I've connected up my 48 volt battery bank to the solar input. You can see that XT60 right there is connected up. So that's going over here to this large 48 volt battery bank, and over here I have a bunch of DC breakers, so I'm just tying into that. So let's take a look at the screen. So it allows us to charge with the built-in solar charge controller. We can charge via the expansion battery port, and we can run 240 volt at the same time. So just wanted to make sure that works properly. Okay guys, I'm really excited for this final test where I basically connect up my 48 volt battery bank directly to the F3800. So I have this adapter here plugged into the expansion battery port. The SB175 is over here. I have 1/0 wire going up to these bus bars with a 125 amp breaker right here. So they are all tied together now. So these bus bars are tied into these 48 volt batteries. So I have a 14 kilowatt hour battery, a 16 kilowatt hour battery, and a 5 kilowatt hour battery. These are all 51.2 volt nominal batteries, all tied together in parallel, going to these bus bars. And so now those batteries are feeding the F3800. So can you use a bunch of DIY expansion batteries on the F3800 through that expansion port? Now I have the 240 volt output enabled, and that is powering my transfer switch right now. So I have all 10 circuits enabled. And if we look at the screen on the Anker, we're seeing a little over 350 watts. And it's going to go on and off basically as fridges run, lights turn on, microwaves, things like that. So this experiment is just to see can this just keep running as it feeds off of these 48 volt batteries? Now, the good news here is that I have these charge controllers. Now, I've wired my 1600 watt array and my 1200 watt array into these charge controllers. So those are going to feed these 48 volt batteries, and it'll also feed the F3800 as one giant system. So I don't know, maybe we'll check in later tonight, but right now everything looks good. Now, just a quick update before I head to bed. The sun went down about 4 hours ago, and the power station is still at 98% state of charge. And you can see with the current load, it's estimating 3.3 days until the power station runs out of juice. Now, I have not seen any issues with the 240 volt output. Everything's running off the transfer switch just fine. Basically, I will check in the morning and see what the power station is at. Now, I'm a little worried because tomorrow it's supposed to be a cloudy day. I was really hoping to use the 2 large solar arrays to charge everything back up. We'll just have to see how it goes. But this is a way longer runtime with these batteries connected up versus the power station on its own. So it's the next morning, and I'm actually a little surprised to see some sun on these panels this morning. Doesn't look like it, but we do have just a little bit of sun, so maybe we can charge these batteries up today. Let's go ahead and take a quick look at the charge controllers to see what we're bringing in. 123 watts. I have to push the button here to see. 160 watts. So yeah, bringing in some good power this morning. Now, I'm getting more familiar with the screen and how it works during this type of test. And whenever you have a high estimated time remaining, like right here, we're showing 27.9 days, that means the power station is charging. You can see we've dropped down to 90% overnight, so only 8% drop. And we are currently running 225 watts, and we have more than that coming in. And that's why it just went up to 99.9 days. So the power station is charging right now. So the test has been going for over 24 hours now, and if you look at the screen, the F3800 is fully charged. The estimated remaining time until empty is 90.8 days, and we're running a 378 watt load. Now, the batteries are also fully charged, which is a good sign, so everything's kind of syncing together. Now, I was a bit surprised that I got enough solar today to charge this up. I was expecting a bunch of rain and clouds, but hey, we didn't get that, so it worked out well for the test. Now, this was a super interesting test, and it appears that these standalone batteries just work in tandem with the F3800. We were even able to charge the external batteries with external charge controllers or battery chargers, and everything kind of just worked as one large system. Sure, you lose a little functionality of the screen. You don't know what's going on with the external batteries, but you still get this state of charge that appears to function properly. Now, what did we learn through all of that testing? Well, basically, if we use a cable like this to connect up to the expansion battery port, we can use our own expansion batteries, we can use AC chargers, we can use solar charge controllers, and we can combine all that into one giant system. So pretty interesting test results. Now, I will have a portion of the video here at the end where I walk through making this cable. And just FYI, this is the way that I made it. You can basically use any type of connection method. I don't think there's a right and wrong way to do it. Now, there's one other test that I want to do because I have the F3800 and I also have the F3800 Plus. I'm wondering if we can connect them together. Now, for this test, I purchased this $100 Anker battery expansion cable. Now, unfortunately, this is not available on their website. I had to buy this from a third-party website, which I'll include down in the video description. Now, you'll cut back the mesh that protects the wires, and then there are 5 wires in here. There are 4 conductors, so you have 2 positives and 2 negatives, and then you have this communication cable. You have to cut the communication cable for this to work. So right here we have the F3800 Plus, and right here we have the F3800. Let's get this connected in here. So that's clicked in, and then you just come in here, click this in on the other power station. And then what I'm thinking is if we turn on one of these, it should automatically turn on the other one. Yep. Okay, they're both turning on. Now, with any of this testing, it's super important that your batteries are at the same state of charge. So these need to be at the same state of charge. Same with any expansion battery that you connect up, you always want it to be the same state of charge, and having it at 100% state of charge is going to be your best bet. Now, since we have both these batteries connected through the battery expansion port with no communications, their batteries are essentially tied together in parallel, so they should be the same voltage and state of charge. So if we're running a load on one of them, the other one should catch up eventually. So what are the perks of this type of setup? Well, you get double the capacity. You have two inverters that you can run if you want to, but you also have the ability to keep the 240 volt running. For example, if you want to run a load on the F3800 Plus on the 240 volt output, totally fine. But what if you don't have solar to charge up? Well, connect the F3800 to AC charging, and it will share the charging between both of them, and the 240 volt output will stay enabled. And we'll be testing that here. So what I want to do is put a load on the F3800 Plus, see what happens to both of these. After that test is gone for a bit, I want to try charging up the F3800 and see if it charges both of them back up. So I've started the test. I have two 500 watt heaters running off the 240 volt output, and I have each one running off a leg of 120. So that's what that adapter does. If we look at the screen, we have 942 watts going out of the power station. I want to get a clamp meter and just see how much power is going through this cable. So check this out. I have my clamp meter on two of the conductors, and we are showing 9.63 amps. So even though the power station doesn't have the inverter on, it's just powered on, it is pulling power through the cable to charge the F3800 Plus. Now, going back to the F3800 Plus screen, which is running the load, take a look at the estimated time remaining. So it's estimating 7 hours for the 1000 watt load. And that's because our combined capacity together is about 7,000 watt hours, because each one of these units has 3,500 usable watt hours. So the estimated time remaining seems pretty accurate to the test that we're running. So I'm going to let this test run for an hour or two just to see what happens with the state of charge. So we'll see you back in a couple hours. So it's been about 2 hours. The test is still running. One power station is at 78% state of charge. The other one's at 76. So they actually did stay pretty similar in state of charge, and they are sharing the load. So now what I want to do is connect the original F3800 on the left into AC wall power to see if we can still run the 240 volt on the F3800 Plus. So I'm just gonna take this and plug it in. So I've connected the charging cable. We are getting 1718 watts input. Now the great news is, even while charging the original F3800, the F3800 Plus is running the 240 volt load. So it still has the 1000 watts going out, but look at the estimated time remaining. It's jumped up to 99.9 days, meaning that we are putting more than 1000 watts into this power station, and that's why we're getting such a long estimated runtime. So this was a pretty interesting experiment. So you basically get double the capacity. You have the ability to AC charge the power station while having 240 volt output, and you also get the ability to have double the solar inputs. Remember, you have the two solar inputs on the F3800 Plus, and you also have the two solar inputs on the F3800. Now to finish out this test, I've shut off the heaters, and I just want to see if this AC charging cable will charge both of these power stations back up to 100% state of charge. So I'll come back in an hour or two to see if these are both fully charged. So while the power stations were charging up, I heard a relay click down the hall. So I came to check it out, and look at that, the inverter shut off. So I'm not sure what caused the inverter to shut off, because it was just charging, but we can turn it back on. So let me go ahead and do that. Maybe it needs to be running a small load. Not sure, but the inverter's back on. We'll see if it shuts off again. So at the end of this test, both power stations did get up to 100% state of charge, but unfortunately the inverter shut off a second time on the F3800 Plus. So I'm not sure if this is reliable enough to recommend, especially if you need to keep that inverter powered on, because something between these two models, well, the F3800 Plus is not liking that, so it's shutting off the inverter. So I can't say that I'd recommend this type of setup. Now, I will say with the earlier test that I did with the DIY expansion batteries, the solar charge controllers, and even the Chargeverter or AC charger connected in, as long as you stay under 55.5 volts, the inverter should stay powered on. I did do some extra testing off camera, and when I went above 55.5 volts, it did trigger the inverter to shut off. So maybe that's what's happening here, but since the F3800 is charging the F3800 Plus, you'd think that it wouldn't go over 55.5 volts. I'm not sure. So those are the tests that I've done on both of these power stations. Now, I've tried to kind of figure out what I want to say here. Like, these are expensive products, and I don't want you guys to waste your money or break your products. So definitely continue at your own risk. And would I recommend this? Well, I don't know. I definitely wouldn't recommend connecting both these together because it just wasn't reliable. But the fact that it was okay to connect in your external charge controller, or even having the DIY expansion batteries connected up for over 24 hours worked just fine. So I don't know. Just continue at your own risk. You guys can choose what you want to do. Let me know what you think about these type of tests. We have seen some power stations go this route. For example, Pecron released a cascade cable adapter that allows you to get direct access to the 48 volt battery inside. And even Montech released a power station, the Montech X1200, that allows you to use your own expansion batteries openly. Like, they just welcome it. So pretty interesting that the industry is kind of going this way. And the first company that comes out with a large power station like this that allows you to connect up a server rack battery straight into it is going to get a lot of sales. Yeah, cool. Well, this was definitely fun. Let me know what you guys think. We'll see you guys in the next one. Now, before we get started here, I want to give a shout out to one of my viewers named Bill, who actually sent me half of his cable so I could do testing here. Now up here, we are going to see a screenshot of the port on the power station, and then I'll break down the polarity here. So this is the top of the connector, and it plugs into the power station like this. So if you look at the power station, you have 4 different conductors. On the left-hand side, you have 2 negatives. On the right-hand side, you have 2 positives. And that correlates to this port here. On the right-hand side are the 2 positives. On the left-hand side are the 2 negatives, and there are actually 5 individual wires or conductors that go along flat. So the 2 on this side are the positives, these 2 here, and then the 2 that are on this far side are the negatives, and then the cable going in the middle is for communications. Now, in order to get easier access to these conductors, I've cut back the braided sleeve with just some snips. And I've also labeled the wires. I've labeled the 2 positives and the 2 negatives. And I've also plugged this into the power station when it's turned on and tested with the voltmeter just to verify that everything's accurate here. And I recommend you do the same thing. Now, the next step in the process is to determine what you're going to put on this end of the cabling. So how are you going to connect it up to whatever battery or charger you want to use? So what I've opted to do is use an Anderson SB175. And these 2 AUG terminals appear to be well suited for combining 2 of these wires into one. So I have 2 of the positives that are going to go into one, and I have 2 of the negatives that are going to go into one. So I'm going to have one SB175 at the end of this cable. So what I've done so far is I've scored the rubber insulation and pulled that off using a utility knife here. And now I'm going to combine these together and put it into this and then crimp it down. So I've just finished crimping this. I like to do crimps on both sides. So you can see it's double crimped. And then with these Anderson tabs or these terminals, there is a kind of a clip here. And these are the positive. So you can see it will go into the positive, and then it clips on the end of this metal spring right here. So that's what locks it in place, is you slide it on that and it clicks into place. So you want to do the negative in the same exact orientation as this so that they both click down onto this connector. So I have both the positive and the negatives ready to go. So all we have to do is slide them in and they clip in. It's just super easy. Then you take the other side and do the same thing. Okay, so then all we have is this communication cable left over and everything's ready to go. Now the final step, once you have the connector assembled, is to plug it in, turn on the power station, and verify polarity. So with the voltmeter connected in, positive to positive, negative to negative, we are getting 53.2 volts. So everything looks good. Now for the final step, I used a lighter to melt the plastic here so that it doesn't fray. And then I also trimmed back the communication cable here so it's just out of the way. So that's basically everything.